Hello, my name is Maydan. I'm a software engineer working in ML space, and I'm very excited to be here and share with you in this session what I did lately. So let me start by a short story, personal story. COVID-19 had left the startup I was working at in a tight spot. My family homeschooling. It also created an option to fulfill a long dream and build something of my own and chase my own star. But at that point, I had a blackout and all the great ideas I had before were lost in the fog. So I decided to just start moving and solve a problem I faced before I will probably meet again, which is content authorization. This is how the ShareIt project came to be. Since then, I have few great ideas, and one of them was even chosen, and I will happily spend years building, and ShareIt is indeed part of it. So I will be talking in this session about TypeDB for content authorization, or the ShareIt project. What to expect from this talk? First of all, why? Why build a content authorization system? Then what was done and how? Then we have a demo and summary at that. But isn't content authorization a solved problem? There is RBAC, there is LDAP, OPA, also many application-specific solutions. So why? Well, I perceive the organization of the data and the access management as the blood system of any data product. Yet in the past, I delayed solving this problem and treated it as non-core. At the end, I relied on existing solutions which weren't what I wanted. Building such a system is a lot of work and it always seems like a bad return of investment. Specifically that I wanted access management for data objects, not files, not microservices, not APIs. I wanted it to be easy managed by the users themselves, which make it a bit like a social network. And again, building those things is a lot of work. What exactly did I want to build? A clear organization of the data, easy manage many users and data objects, have ability to define advanced access rules. I wanted to answer many questions like, does a specific user can access a specific data object? If so, why? Who can see this data object? What specific user has access to? If I make this change, what would be the impact? Here, TypeDB came to the rescue. Let's see what a few simple rules can do. Let me start by introducing the basic entities. A user, I was hoping by that time to look like him. A user group, which a user can be a member of. A thingy, which is a data object, let's call it. And a tag, which aggregate thingy, and a thingy can be a member of a tag. What we want is that to have a access right set between either a user or a user group to thingy or a tag. So how it can be done? Okay. First of all, a user can be a member, we say, of a user group. And a user group can be a member of other user groups, which make him a member of this user group. Also, this is, we know, is a simple rule that very common in Bracket. We have G1, we have G2, G1 is not G2, and if user is inside G1 in group 1 and group 1 is inside group 2, and then the user is inside group 2. What's beautiful is it can be built in layers. So a group can be inside group, inside group, inside group, and the user will be a member of all of them. The other part of it is the tag. A tag can be a member of other tags also. It's important to notice that a tag can be a member of many tags, so it's not limited. And here is the rule that should show it. T1 is a tag, T2 is a tag, T1 is not T2, is not T2, and object. If you have an object which is inside container T1, and T1 is inside container T2, then the object is inside T2. Until here, everything is very, very easy. But what we want is to have the user have access to the thingy, to ask if it has the access. So here comes the third rule. We have a tag, a user group, a user, and permission set, a specification of permissions. And if the user is inside the user group, and we have access between the user group and the tag, then we have access between the user and the tag. How does it look like? If a user have access to the group, is a member of a group, and the group have access to the tag, then the user have access to the tag with the same permission set. Now, for the last rule. If we have a tag, thingy, a user and permission, and the thingy is inside the tag, and we have the user have access to the tag, then the user will have access to the thingy. So we left off in this position in the previous rule. So the user have access to the tag, and the thingy have a membership in the tag, then the user have access to the thingy. As you can see, by chaining few simple rules, we could achieve quite a lot. Very simple, but it can get us very far. One small addition, a thingy is a tag. In the Kraken language, it inherits from tag. So everything can contain other things, and everything is can have access right, which will propagate downward. I will reference it as if it is an aggregator of things, it will be the reference as a tag. But if it's a data object by itself, it will be referenced as a thing or a thing. So what is a thingy? Well, the options are endless. Let's imagine we build a simple kind of to-do list application. So we will have epics, maybe features, user stories, customers, all of them are tags. Underneath each one, we can make the hierarchy deeper and have more epic 1, epic 2, user 1, user 2, and so on. Let's have we have a to-do item now, a thingy which is to-do item. It can be inside epic 1, it can be inside also customer 2 who helps developing it, for example. Now, we say that the thingy can contain other things. So it contains maybe a document. Here, now it contains a document inside the thingy. And this document have paragraphs, and it have another document or another to-do item or an image file, or maybe a tag which in itself contains image files. And for each part, we can set permission as we would like. So, and they will go downward to contain the object. What else can a thingy be? On another track, a thingy can be a representation of a mechanical part. It can have issues report, upgrade option inside of it. It can be contained and it can be of a certain type. It can be inside the several assemblies. Each in itself can be in multiple products. For my own product, I'm building many raw things, including to-do item, document, personal notes, media file attachment, chat, and more. And all of those are built to be served through APIs and with the full functionality and augment other products. Answer to a question that frequently arises is if a user is given a permission for multiple tags, for example, so what will happen? Well, the maximum permission set will be selected. So if you have, if it's in numeric type, it will be the max. If it's a bool, true will be greater than false. So, and if it's an enum, there is also will have the max, which there is a way to define how they are ordered. Things can be in similar levels, a few things, so it will not change them or it will aggregate it. This is done. We can define access specific that is out of hierarchy. It's very important. For example, if you have a document and you want to have a paragraph which is a draft, maybe it's personal notes, maybe it have personal to-do items. You can say, this is out of hierarchy. It's not inside the document. It's only I can see it. And it worked well. And what's beautiful is it's another connection to a tag. So everything will go downward in this way. And when you can share it, you can decide, I want to share my draft with someone else. And at the end, if you want to return it to the regular flow, you can just sever the link and it will return to the regular flow of things. So this is also part of sharing. You can also define a membership in a group, define multiple member subgroup membership. It means that to be in a group A user must be in both group B and C, for example. So this is a way to control access right also. And to know you have the specific combination of groups or roles that you put the user into. What's next in this project? Well, more dynamic permission settings, which means that the permission now are quite standard. If the user can reshare what I shared with him, if he can change it or not, if he can delete or add things from the inside the thingy, and so on. And there is a need to make it more dynamic, which is database, not schema-based. Complete entity management. Part of the system is an entity management, which means you can define a user to do item, whatever you want. I will show it in the demo in a few seconds. And you will have automatic operation like insert, update, delete, and so on. But this part is very far from complete, as for the example, if I delete a user from a connection between a tag and user, and it have on the connection the permission set, and I deleted the user, now I have a relation which is dangling, and I need to understand this and remove the relation. Now I have an attribute, which is the permission set, which is need to be garbage collected. So there are things like this that still need to be completed. Security need to be evaluated by external hackers. Performance still have work to do in optimization, documentation, GUI, mutation audit, and triggers. This is part that need to be also for the entity management, which means that every time there is a mutation, I can both audit it and activate triggers around it. Demo time. Well, I will look at the questions. The setting is less appropriate. I will look at the question and I will show you the demo, and then I will answer any questions I can. So let me show you. Here is part of the test, and we have a test here which was prepared for Orbit. And while it's creating the schema and everything, and preparing everything, which is usually finished. I will show you, when I say creating a user, here is a description of a user. Well, it have an email, it have optional alternative emails, which will be written if there is, and I don't know how many, first name, last name, which can be given or not, and so on. There is also this, which is, it means it's Graken type, which means inside the Graken database, this is how you reference this object in Python. Now, as you can see, it's inherit from entities base, which all entities must inherit from it. And it's very, very thin layer, which in purpose, which is contain only please set the Graken type, please set if it is a thingy to true, and please supply object ID, which if you don't give it, it will create it for you. So let's see back to the code. And as you can see here, I created a user, no only email, and inserted it. And this will represent itself in the database as the following. Here, we have a user. The user automatically gets a private tag, which everything that he creates is he has access to through this tag. And of course, you have permission this, which is for the maximum at this point for him. Now let's create a group and insert another user in this demo. Here is create a group creation. Now he is inside the group, and we have another user. The next thing I'm about to create is a lot of priority team. Priority team is a kind of tag which is weighted. So it means it can calculate various things, how much priority basically you want to put on this, and it's compare it in the to-do item to what you actually did. So another property of priority team, it have a single parent always. You will create a tree-shaped structure, which means it will look like this. This is the structure I created, which is for the demo. All of my time in the top, and home and homeschooling, and home to-do items, work, share it inside of work, and I have development, share it development, and product. This was created until here. Next, let's create. I have a remark. If we look at who the user one has access to share it dev, if it's priority team dev, which is share it dev, it do have access to share it dev development. If we ask why, well, it says you have access to share it, which is, and share it dev is inside share it. If you continue asking the why, we can see that it will end up with we have access to the user tag, and share it is inside the user tag. So let's add to-do items. Here's a group of to-do items I will add. Doing a live demo is always funny and scary. And the structure that was created is the following, which means what we see here is for each to-do item, only its direct parent. So we can see that close Chrome tabs are at work, and prepare presentation for Orbit and prepare demo are inside the product. And what's interesting also is that here we have two tasks, which to-do items, which are inside the to-do item, which just to demonstrate things can be inside of things easily. If you look at it if you look at it with reasoner on, we can see that now prefer presentation for Orbit, for example, sit inside product and share it and work and so on further up the tree. Now, let's do an invitation because this is how adding to a group works. An access right work, and you can change and reduce the access right that was given to you. And there are many reasons why to do it. And I create a lower share false. The share is two directional, and I'm an invite and create the invitation. In this example, it will look like this. No. This is the end result. So if we ask now without reasoning, who have access to what? So user one have access to this private tag, user two have access to this private tag, and he have a direct access to share it. Now let's run access for if we run a test for checking access, we will see. Very excited. Now here come the test, which is here. Let's see who, if user one have access to 8 tasks and user 2 have access to 4 tasks. We can change it and see it specifically, but it will be the easiest this way. And I remind you that we have 1, 2, 3, 4, 5, 6, 7, 8 tasks, but under share it, which is here, we have product and development. So we need to have 4. So let's run the test and see if it works. And it works well. So this was a big kind of a demo and demonstration. The things are actually working, and it's a pass. Let's summary. So what we saw that TypeDB have few unique capabilities like inheritance that allow easy extendability and easy integration of various things into usages. It allows non-bidirectional relation, which a permission set suddenly sits as part of the relation between a user and thingy or a tag or so on. And we saw that chaining a rule is very easy and very powerful because a user can be inside a group, which is inside a group, which is inside a group, and a tag can be in a tag, and thingy can be in tag inside tag inside tag. And chaining only the upper ones will have access to propagate the access right downward. Inside the share it project, I show you how easily it is to make that object inside other objects. That you can have, everything can have access rights set to him, and they will propagate downward. Share it itself is an infrastructure project to trying to go independent, and I believe it by working with it, it can significantly reduce the time from POC to production. And I'm searching for people who would like to use it, and talk to me if you feel you can benefit from working with it, and let me know your pain points and a specific need. Maybe they are already solved, or maybe they are on the roadmap, and let's talk. I'll be delighted. I would like to say many thanks to the TypeDB team, and Lucas, Adam, and Oleg Kolov, who contribute the animations, my family who's helped me and support and keeping now quiet in the other room. And this is my email if you would like to approach me. And thank you. And if we have questions, let's see and try to answer them. So thank you. And how do I see if there is questions? Integration. How do you envision integration, integrating the concept with other IAM systems like LDAP and IAM and so on? For most of them, I can do a reduction, or basically I can create a policy on the fly and change it, I believe, without a problem. It will be more ugly and less efficient in many ways. It will be a huge one, maybe, but I believe it can be done most efficiently. Yes, and I queried the knowledge graph in real time. It works basically quite well. Read performance. There is several levels of performance. I can show slides I made, but basically for the current phase, I'm tracking performance to Grafana and Prometheus, and also there is audit of the various performance challenging the system with various cases and audit the times. There are lots of places for optimization, and there is a separation basically between the have access query, if the user can read it, or any question that is further, if it can have mutations, which means you need to specifically check a bit further. But the health query is okay, and there is lots of place for improvement. If really depending on performance in real time in 1-digit milliseconds, it is not going to work unless the caching will be very, very efficient mechanism, I think. It takes currently around 20 milliseconds to get an answer. If you have an access, when you are 10 groups deep and query for something which is 10 in the tags deep, 10 levels deep. So queries, the performance is okay, but not still have lots of places for improvement and in the bucket list. Thank you.